Okay, so the recording is already going on. Let's concentrate here on the Java session 3. The content for today is we'll discuss about classes and objects, and I think a number of times in the past as well I have reiterated about classes and objects. They are the very basic things on which the Java language as such depends upon. So we have to be very clear about classes and objects, and related to objects we have constructors and we have overloading. So let's go ahead and see. So what is Java? As I told you, it's a true object oriented language. Everything which is out here in Java, we try to represent it using objects. So the idea is just to the idea is to match everything with the real world scenarios, okay, and try to represent them in that ways. So class represents one particular entity in Java, okay, and you can say it's a blueprint, okay. So it's sort of like
Hi,
say,
Abhishek. Raghav here. So I'm not able to see the screen.
oh, is it? Let me see. Uh, okay. Can you see it now?
No.
Oh, is it? Just a second. I don't know. Can you see it now?
No.
No.
Yeah, it's okay now.
Raghav, you can see it now? Okay, folks, I think you are able to see it now, so I'll start with it. Is it fine? Okay, so let me repeat from here whatever I had discussed. So the course content today which we are going to discuss is about classes and objects. So as I've told number of times before, the very basic thing in Java are classes. They are the blueprints, and objects are the actual representation which we create using for that blueprint, okay. And today we are going to discuss in detail about it. So constructors are used to create objects, okay. And there is nothing on right side. I mean, right side, if I even if I remove it, there is nothing, but I'll just do it. It should be visible now. So so constructors are used to create objects, okay. And overloading is about the functions, the methods which you write, and there are number of methods which can be there in a program. And what do we mean by overloading? We'll discuss it, okay. So they are the course contents for today. uh, Let me go down. So what is Java? So Java is a true object-oriented language we have discussed number of times before, okay. And uh, everything which we have in Java is encapsulated within a class. So class has all the necessary details. So say if we are having a scenario, what we try to do is we try to represent everything in form of a class. So and a class as such can have the state and the behavior. Okay, so it defines the state and the behavior. So class as such has the attributes and the methods. So attributes are basically the, you can say, some of the features which the class which that particular class has, and to access those features we have various methods. Okay, now classes create objects. Is it fine now? So okay. Yes, Suhas can see the whole page. Maybe uh, Raghu can check on his settings because nothing else has to be done from my end. See, I have joined the meeting. There is no setting here, and then I have made uh, the size is 100%. So nothing else
So
is
now it's
required.
good.
Okay, fine. So so classes create objects and objects use methods to communicate between them. So as I said, see, a class has attributes, okay, and to access those attributes we have methods. Now say there can be various classes within a particular project, right? Like say for example, I'm writing an employee management system. So for writing employee management system, I am having say a manager, employee class, then I'm having admin department. So there are various departments such as admin, HR, business, uh, sales, marketing. Then I have employees which belong to this department, right? So we have employees, then we have managers, then we have CEO. So here if you see, there are a number of things which are out there, right? And we can use classes to represent all of them. So there can be one employee class, there can be one like say CO class which inherits all the details from employee and has some additional details. So that is an example of inheritance. Then we can have one class department, and there can be various types of department. So there will be one attribute inside department, such as say string department name, right? And once we have that, like the same thing can be used. So employee as such would be having an access to department. So employee would be having one attribute as department. So in that ways we can represent the entire real life scenario for the employee management system which we have. And that's why they say that if between say I have employee class and I have department class, and if I want to get the details from the department, I need to access some method, right? Like say if I want to get the department, I need to do d dot get department name or d dot department name, where d is just the object name. So there has to be a way of communication between objects, and that's what's written here, that objects use methods to communicate between them. There are can directly access their attributes as well, but again that will violate one of the basic principles which we had discussed before, that is encapsulation. Okay, so abstraction, data hiding. So we are not supposed to, a class is supposed to have some attributes, and on those attributes it is this class only that is supposed to act upon. Now no other class should directly access their attributes, and because if they are directly able to access those attributes, they can go ahead and change it as well, which is not which is not a requirement. They should not be able to do that. Okay, so that's it. Now the next one is, a class essentially serves as a template for an object, as I told you, and behaves like a basic data type. So what is meant by this is that, template is fine. It's the same as the blueprint concept which I was telling about, and the data types which we have, such as say integer, byte, short, long, character, right? So it has some memory location, it behaves in a certain way. Once you create a class and you create an object from it, I mean, you can create number of objects, and every time, I mean, there are some attributes which will be initialized. Some of the attributes, certain default values will be set just because you have configured the class in that ways. Okay, so that's why, I mean, it says, it's being said here that it behaves like a basic data type, and it has methods and it has attributes, and all the basic object oriented concepts such as encapsulation, inheritance, etc. has to be incorporated in the classes. So see, if as I was discussing here uh, about the methods and the functions, now say if I'm directly accessing the attributes of some other class, what will happen? I mean, see, Java as such is not going to kill you, right? I mean, you can go ahead and use it in that ways, but what's happening is that you're violating some of the basic object-oriented concepts which are out there. Your program will still work, but maybe you'll start facing some of the problems because of which such concepts were created in the first place. So in long run, you'll find that your program is not maintainable to that much extent. Okay, so this was the introduction. Now come to classes. So as I told, what is a class? So class is a collection of fields, right? So it's a collection of data. Like say circle is a class. It has center, it has radius, and then it has center, it has radius. Then you have say if you want to access center and radius, then you have to include certain methods such as say get center, get radius, set center, set radius. Now circumference. So for a particular circle, if you want to calculate the circumference, you need to call this particular method, which will operate upon the radius, give you the details, and send the details back. Okay. Now similarly, that's upon the radius. It will use the it will use the area. So it will use the radius and send the area back. So basically, all the methods are out there. Okay, that operate on the data, and the fields or the attributes you define in a class. And inside these methods, you're basically supposed to use these attributes and send the details back. Okay. Now the basic syntax for the classes, as I mentioned here, class name. Then if there is inheritance, as I was explaining like 2-3 minutes back, say for example I have a CEO class. Now CEO is also an employee, so it extends employee class. Okay, so what it means is that it inherits all the features from the employee class. So apart from employee class, it may have some certain additional attributes, like say I mean some perks or whatever, which is represented by some other attributes inside the CEO class. But some of the basic things it inherits just because it's an employee, and that will come because of the extends keyword. So if you want to implement inheritance in your hierarchy, you have to use this keyword. Okay, and then we have field declaration, then we have methods declaration. Now the next one, which is can define variables of that type, say circle A circle, circle B circle, that we're going to discuss right now. So let's not get bogged down by it. This is the diagram. So say when you create an object, okay, like say when you say a circle is equal to new circle, now what's going to happen? So what's going to happen is that in the Java memory, okay, in the Java heap memory, so whenever objects are created, they are they are stored on the heap. So memory location is allocated on the heap. Okay, so in Java memory, uh, certain space is reserved. Okay, and I mean there you have the object, in the sense that if you create a new circle, what should be a default value of a radius, what should be default value of a center, etc., is allocated there. Now that object is created when you say a circle is equal to new circle. So when you say and it has already been defined here, like say here circle a circle, and here you're giving a value. Okay, so coming back here, so circle a circle is equal to new circle. So if that is the case, then with new circle already an object has been created on the Java heap memory. Now what is here, I'll explain about that. Now when on the right, if you see, you have circle a circle. So what is the meaning of that? On the left, so the meaning of that is you have a reference data type. And if you remember in my second class, I was discussing about primitive data types and reference data types. So reference data types are basically the data types which are used to reference that particular object. So here this A circle or say B circle is a reference data type which is used to refer to the object, this newly created object which is out here. So A circle is referring to it, B circle is referring to another new object which you have created. So if you say new circle, okay, you refer to an object. If you say new circle, I mean you can have a question as to whether it will refer to the same stuff which has already been created. No, that's not the case. So whenever you do a new circle, a new object will be created. Okay, and to refer to it, you need to have a reference data type, which in short you can say a reference variable. So a reference variable is always of the same type, which is of the same object. So if the object is of type circle, the reference data type which is out here, oh, I'm sorry about this. So the reference data type which is out here has to be of type circle. So if you go above and see, you have type circles defined, right? Circle is defined here. Now if I go below and say that circle is out there, fine, but what about, I mean say, what about inheritance is out there, right? So what if you have to refer to inheritance, what we need to do? What if you have to refer using interfaces, what needs to be done? So there are certain things out there. So let me like discuss right now only because we already brought this topic up. Just a second. And I hope that you are able to see it. So when I say circle, A circle is equal to new circle. Okay. Now this is one way. When I say circle, A circle, now this means that I have already defined a reference data type, just that this reference data type is not referring to anything as of now. Okay, so just created, not referring to anything as of now. Okay, and once you assign it some value, it will get created. Okay, so this is one way which I have explained here to explain the concepts about objects. Now say I was discussing about inheritance, right? Now it's important to understand how like we use this reference data type can be of various types. Okay, so one type is that you have exact same class. So if it's circle, the reference data type is also of type circle. Second is it can be the inherited class. So what is meant by it is like say I was discussing about employee, right? And I was discussing about CEO. Just okay, let's hold on to that. Give me 2 minutes. Let me complete this part. We have employee and we have CEO. Now say CEO was supposed to inherit all the concepts about all the things about employee. So I created the class CEO like this, right? Now I have a class employee and there is another class which I created with CEO, which extends employee. Okay. Now say to represent CEO class, I can have CEO1 is equal to new CEO. There is other way as well. To refer to the same CEO, I can use employee. So this is possible. Okay. So now what's happening is that using this EMP, you can refer to the newly created object which is out here. Now the only caveat is that once you start operating on this object, now see, once an object is created, it's not that you can refer to it. So when you do like this, say new CEO dot get privileged status, this is going to create a new object. Okay, this is not going to refer to the existing object which you have created. So once an object is created, the only way to access it is through reference variables. So there has to be a variable referring to it, or you need to immediately use it. Okay. Now let's go back to the things which I had explained here. So it has to be either the same type, same class, or it can be representing inherited class. So if you see the reference data type which is out here, which I defined, is representing the inherited class. Okay. Now employee EMP is equal to new CU. Now in this way we can refer. The third way is using interfaces, and I think we have not yet gone out there, but let's define it just for your sake. So what are interfaces? Now interfaces are, say we discussed about classes, right? So we have classes. Now classes has attributes and functions. Now interfaces as such is just a contract. So say in object oriented world, if I have to deal between two classes, okay, like say employee and department. So if I have to deal between these two classes, what all do I have? I mean, I have the attributes and functions of employee, and in department I have attributes and functions of department. And to interact between them, I use number of methods, like say get department name, or this department has the method get all employees. So we have these kind of methods out here and the attributes which belongs to it. But say for an example, I mean I come out here and I have to implement say I have to implement a DAO layer. Now what is DAO layer? That is in data access object layer. So basically what you can understand from this is that to access the database, we need to write certain classes, okay, and that basically constitutes the DAO layer. Now the classes whatever I write there, say tomorrow depending on the databases which you have, like say for Oracle, and this is just an example to explain you help better. So you have different databases like say Oracle, you have DB2, you have MongoDB. So for every DB which you are trying to interact, the methods differ. The underlying way in which we try to connect with that differs, but the method signature etc which we want from our code to access should remain the same. So in that case what we do is we define an interface. So interface is nothing but a collection of methods, okay, and saying that this is the contract and we're supposed to use it in this way, okay. So once you define an interface, it can be implemented by different classes, okay, and once the class is implementing it. So say for an example, I define an interface IDAO, okay, and then I have an employee DAO class to save the data in the DB for the employee class. So employee DAO has to implement an interface. So it implement the DAO, okay. So once it does that, the same way as whatever I have done here, you can use an interface name to refer to the employee class. So in here if I say, I can use IDAO to refer to the employee DAO. So there are three ways in which the reference data type can access the objects. It can refer to the objects. One is exact same class, inherited class, and interfaces. And maybe interfaces will deal later as well, because we have not dealt till now, but we can like use it in this way. Yes, more than one reference variable can refer to the same object. So that's possible. Say for example, I have employee EMP is equal to new employee, okay, and so this is referring to this particular object, right? Now I can also have something like this, where employee EMP1 is referring to EMP. So this way we can have number of reference variables referring to the same object, but not like, I mean if you create like this is actually a new object, it's not referring to the same one, okay. And to answer your earlier query, heap is a type of memory. So we have stack memory, we have heap memory, there are other such things. So it's just a type of memory. So this is what's about the circle and the other classes which are out there. Interface have not implementation methods. The interface doesn't have implementation methods, it just has the definition. Okay, so like say if I go here and start this training stuff, and create an interface. So in this way you'll say an interface. Here you can define all the methods. Okay. Yes, it has to be implemented in classes. So like say if you define public string get or save details, okay, and you have to pass an employee object, maybe say here, or just ref type object, okay, then whatever classes you write, I mean somewhere out there you have to have some implementation for it. Say for example we'll define one employee DAO, okay, and this has to implement this interface. So it is like I'll go ahead and implement IDO. So now say this, since it's an ID, by default it says that you must implement the methods because you are implementing the IDO. So one way is that you can go and manually write it here. What Eclipse gives you an option of is just go and add unimplemented methods, and it puts the implemented methods here. Now here you define all your whatever you have to do, like go to DB, save the data, okay, and then you return a value back. Okay, so this is how we do it. Now say if I go here and write another class just to test it out. So if I write say let's say test employee, okay, now if I write a test employee, if I run it, the default method which gets called is main method. I'll define the main method, okay, like this. So there are various ways of creating a main method using an Eclipse IDE. One is once you create a new class, you see an option here. Which method stubs would you like to create? You click on it, IDE creates it for you. The other way is you go and write it manually. This is a standard method, public static void main string args. Okay. Or the third way is that once you go here, just type main and do control space. So once you do that, Java gives you multiple options, but since in this case only one option is available, you get it, click on it, you get the method details. Okay, so this is how you write it out here. Now as I was saying about the interfaces, so you have IDAO and there's an object, the reference variable, and it can be used to refer to the employee DAO. Okay, and once you refer to it, you can access the methods which are defined out here. See, save details are here. So I just wanted to write this out to show it out to you that this is how the interfaces can be used to refer to the objects. Okay. Now let's move ahead. Yeah, Nirali, you're right. Abstract class has to have at least one abstract method. Now let's go down. What about garbage collection? So one question, from every person who has created a language can be about the memory management, at least in computers. So here if you see, I am creating a new object, right? Now if you go back to the PDF and if I go above, I created two new circle objects. Now these are small objects, so it's not going to have problems. But you can have objects which have list of items, and those lists have all the details from the 3 crore employees which are there for that particular company, or maybe 3 crore customers which are there for that particular company. If that is the case, you have so much huge data, then you will have multiple objects as well to represent all those employees or maybe those customers if needed. So at some point of time you'll have to do garbage collection. Now what garbage collection means is, and now the names which people in Java have put it, and I think that's the same in other languages as well, is to use very common intuitive words so that you can understand it as well. So garbage collection means collecting the garbage. So that basically means that the objects which you have created, if they are no longer in use, okay, that can be removed. So how Java determines that an object which is out there is no longer in use? And again the reference data type comes into picture here. So if you see this, employee emp is equal to new employee. Now Java finds that there is one reference data type employee emp which is referring to the newly created object. Now say after the work which I have done, like say get save the data in the DB, okay, if I have done this, what else is required? Maybe nothing else. I just have to return the control back to the main program. This might be my only requirement. So I can say that this reference variable is of no longer of any use to me. So I'll assign it to null so that no one else is able to use it further to operate on the employee object which I have created. So this means that the reference data type is now pointing to null. Now when I define the reference data type in the starting, like say like this, the default value is null, so it is being initialized to null by default, and it is only being assigned some value when it's referring to the actual object. Now once the work is done, you can again assign it back to null. Okay, so now once the value is assigned to null, that basically means that there is no reference to this newly created object. And once there is no reference, Java knows that this object might not be getting used because there is no reference data type referring to it. So in that case, such objects become eligible for garbage collection. Okay, so that's what I've explained here. The object Q does not have a reference and it cannot be used in future. Thus the object Q becomes a candidate for automatic garbage collection. Okay, now who does garbage collection? Like say manually as a programmer, do I need to go and mention somewhere here, like once I make say for example do as null, do I need to do something out here to actually start the garbage collection for this employee do class? No, Java takes care of it. So once you make it as null, it has the garbage collection algorithm running in the backend, which finds out such objects which are no longer in use, okay, and then removes the memory allocated to them. And that's what I have mentioned out here. Java automatically collects garbage periodically and releases the memory to be used in the future. Now, how to access an object? Now say we have defined the objects, right? So say I have an employee object out here. Okay. Now I hope it should be visible. So I have an employee object out here which has various attributes such as employee ID, name, salary. Now let me put it out here. So if you have employee class and you have attributes here, employee ID, name, salary, and you have the other methods as well to access it, right? Now coming back here, say somewhere else you want to access the attributes. Now the circle class which was defined, it had the attributes as say, what is the center, what is the coordinate of it, what is the x and y coordinate, and what is the radius. So it had three attributes, x, y, and r. So similarly, the employee class which is out here, it is having attributes. It is having the attribute as employee ID, name, and salary. Okay. Now once the attributes are out there, like you can refer to it from the other classes as well. So as I was explaining it out here, if I see this employee classes here. Now the test employee class which I have written, I can have the employee class instantiation here. I can create an employee class. Now if I create an employee class, I can access its attributes and methods here. Okay, so let's try to do it here. Now methods I can see set department, set employee ID, set name, set salary, but I'm not able to see the actual attributes. And that is, why is that so? Because of encapsulation principle in object oriented world, which we discussed in the first class. Okay, And remember, in one of the demo classes as well, as many would have attended it, I was discussing about access modifiers. So you have public, protected, and private. So what private does is, it means that this is uh, this can be only accessed within this particular class. And if you want to give an access to it, you need to define other methods using which you can access it. So see here, you can't directly access attributes, but we have already defined methods. If you want to set the value employee ID, use this method. If you want to get the value in the employee ID, use this method. And say getting the employee ID, or say getting the name, what does that mean? That means that there is some state of the object, and when I say state of the object, some value is set. So employee ID has some value, sorry about that, employee ID has some value, name has some value, salary has some value. So these represent a particular state of the object. So to get the state of the object, you can refer to these methods. Okay, and that's the reason, I mean, we're not getting it out here because of the private access. See, if I make it as public, okay, let's go back here. So if we go back here and see, I have employee ID here. So I can refer to it, I can even set the value. Okay, so this can be done. Now, that's what I have explained in the PDF as well. That we see the circle, they're trying to set the values here. So to access the data of the object, you can create object name dot variable name, or object name dot method name. So here, see, employee name, so this is object name dot the actual attribute name, or to call the method employee dot get employee ID. So in this way you can do the reference of the data which is out there in the object. Okay, so this is what I explained here. Now I think Akila was asking a question about this. So this basically represents this particular object. Okay, so if I go to say employee class, so in employee class, I mean, you have this dot name. So what this dot name means is, this refers to this particular class. Okay, so if I say employee as like I created an object here, if I do emp dot set name, okay, and once I do set name, the value which I pass is say Akila. So if that is the case, what will happen? So set name method will be called. Okay, the value which we are trying to pass is Akila, which gets out here. Okay, now this dot name is equal to name. So what this means is that this attribute of this particular object name should be assigned the value of Akila. Okay, so I could have written it out in this way, but the only thing is that in this, by doing so, it becomes I mean it's not clear, because the name is the name of the value which you are the name of the variable which you are accepting as an input, and the same is the name of the employee attribute. So to avoid that confusion, we use this, just meaning that it's referring to the same object of this employee class. Okay, now let's go back to the PDF which I had. Now see, to write like say when you go to a particular class, say employee class, if you want to run it in an IDE, what you need to do is do a right click, okay, go down, run as, and then run as Java application. So a server you can run it there, but run as Java application, since you're writing main programs, that will do. So similarly, if you do that and run it, the main method will get called, and here if you see, this code which is out here will get executed. So what it does, it creates a new object, sets the x and y coordinates, sets the radius, and then calls the dot area method. And what dot area method does, it calculates the area and returns the value back which you printed out here. Okay, and then a circle dot circumference, and you have the details. Okay, so this is how you access the variables and the methods from an object. Now let's go below. So what would constructors? So what are constructors? So constructors, I mean again the name is very intuitive. Constructors are used to construct an object, right? So constructors are, when you say new circle, this thing is referring to a constructor. So constructor is actually used to create an instance of the object. They have no return type, not even void. They can take access modifiers, but they cannot be abstract, final, native, static, or synchronized. Okay. Now let's not get bogged down by what it is written out here. We'll try to understand it using an example. Now see, I do not have a constructor here, but I can add a constructor. Okay. If I write say public employee, so I've defined, if you see, I've defined two attributes here, EMP ID and the name. The name is system, the EMP ID is 1. So what this means is constructor, this particular piece of code is always called when an object is created. So when you write employee EMP is equal to new employee, a constructor will be called. But you can ask the question that in this case there is nothing defined from before, whether I need to define it explicitly or how does it work. So if you do not write it, what Java does from its own side is that in the class it adds a default constructor. So the actual class which you will see will be an empty default constructor created by Java. Okay, and because of this you are able to access. This works out, but you need to have a constructor. But if you want to do something specific, like say the employee name, there are various employees for which we do not want the name. The name has to be default system. Okay, so in that case you can set a default value in the starting, and then later on once you create an object, you can access one of the methods which are defined here to reset the value. Okay, so constructor is basically to initialize the value in the starting and to create the actual objects, and that's what I have referred it out here. So it's used to create an instance of the class. They have no return type. See, here if you see, there is no return type which is being defined, and there's no return type, not even void. And the thing about constructors is they can have various forms. They can be overloaded, and when I say overloaded, method overloading is one of the things which we have to discuss today. So we'll discuss on it, but just to understand, constructors can be overloaded as well. And what that means is it can have some of the attributes which is different from the attributes which you passed in the earlier constructor. So if you see this constructor, we are not passing any of the attributes, but here we are passing say employee ID. So this means is that from somewhere else, if you're trying to create an object, you can use this constructor as well and only define the employee ID if you do not want to define the name as system for such employees. And you can, if you go back and check from here, you'll get the example also. Like say if again I'm trying to use a reference data type for creating a new object. If I do that, for doing this I need to press Control space, so that gives you options. You can see the other option is employee string employee ID. So I'm getting another constructor for me to create the object. Okay, so constructors can be overloaded, which basically means that we can pass different parameters from what we passed earlier. Okay, now constructors can be abstract because the implementation of constructor has to be in that particular class itself. You can't delegate it to other classes. It cannot be final. You can go ahead and like call it from somewhere else. Then you have say native. Native denotes anything. Native denotes the native APIs which are there. So native APIs means that I will say you can write code in C and use it in Java. Okay, that's how if you go to the operating system level, the very basic classes are written using C. Now those how is it being accessed? They are accessed using Java native libraries, and such methods you need to mark it as native. But again, coming back to the constructors, so these constructors cannot be native. Okay, they cannot be static. So static is basically meaning that only one copy for a particular class, and in case of so if you create thousands of objects, you'll have only one value for it. So that is not true for a constructor, right? A constructor has to get executed every time a new object is created, so it cannot be static. or synchronize. So synchronize is something else. Let's not get into it. We'll discuss about synchronize when we discuss about threads, which is in one of the sessions which is yet to come. Okay. Now if you use this here, like say if you see this example which is out here, we are using there is one default, there is one constructor. Again, see there are two overloaded constructors, one without any attributes, without any variables, and one with a variable. So here we define the name as input, but here we are passing this and then in bracket John/Mary Doe. So what this is doing is that this is used to refer to the other constructor itself. So here if you see, it's calling this particular constructor using John/Mary Doe. Okay, so this is how it's being referred. The other thing which I wanted to mention about is, say you have not defined the access modifier here, right? So any method, so constructor is also a method. If you go here and see, we defined some of the other access attributes here, whether it's public or private or protected. Now if you do not define, what happens in case of constructors only is, if you do not define, it uses the same access modifier as that of the class. So here by default this is public. Now if you would have created a private class, by default, unless you make it specific, it was private. And if you mark the class as protected, by default it is protected. So that is another thing which I wanted to discuss about this. So this is all about objects. Now it's high time that you can you start using the ID which you installed, create a sample project and start creating objects and writing main methods and start playing with it, because this much information is sufficient for you to go ahead and start writing code. Okay, and again, so for writing the project, so you can create a new Java project and you have to give the name, then you can create such projects, and inside that you can add classes, etc. Okay, now let's go down. We'll discuss about overloading. So I already gave you a hint about overloading, because here we discussed about the attributes which are out here in this constructor. So method overloading refers to the same stuff. So it basically means that you have the same method name, but the parameters which you are passing inside that particular method can be different. Okay, and say the scenario is, and again, I mean, in Java they have not created all the method just because, I mean, it sounded good and it sounded very mature. They created all this thing because there is a need for this. Now say in object-oriented world, if you are having, say, a class such as shape. Now if you have a class such as shape and it has methods such as area, now that area can be calculating the area of a square, where you can have, say, length and breadth, or it can be having only the radius. So in that case you have to define two methods, right? So one method will be, say, public long area, and then define int length, int breadth. Or the same class you can have the chance where you only work on the circle. So in that case you can have only one, which is a radius. So in such ways, if you see, there is a need. So the shape class actually can refer to a circle class. It can refer to a rectangle class, or it can refer even to a square class, right? So in square, length is equal to breadth. So we can have these two methods. Now these two methods have the same name, area, but the attributes change, because in one case there is a different shape, in the other case it is a different shape, but they both are shapes. So in the design which is done, there is only one class which refers to it. So if that is the case, then we have to define two methods if we have to calculate area and if we have to account for all the requirements which we have to write. So if we define such cases, like if we define these two areas, okay, length, breadth and area, so these two methods are called as overloaded methods. So it basically means that there are more than one method in the same class which have the same name but different parameter types or size. Now again, since I've gone there, so method overloading has two things. One is the parameter list can be different. Okay, and the second thing is the parameter type can be different. So this, what I explained here, is an example of overloading. However, just one example, I mean, I'm not saying that it's a valid scenario, but there can be valid scenarios in the real world, but not in the case of area. You can have a length of type string and only breadth of type integer. So if that is the case, these two methods are also called as overloaded methods because the parameter type is different, although the number of parameters were the same. Okay, so even if the number of parameters is same but their type changes, it's called as overloaded method. But say here the access modifier define it as public, and here if it define it as protected, will that mean that there are two overloaded methods? I mean, this public or protected or any other access modifier as such is not used to say that whether a method is overloaded or not. The only definition is about parameter types and the number of parameters which is there in the overloaded method. Now let's come back here. So let's see an example. What is out here? So here we have a method. So there are a number of versions. One version is we have sum of params, no attributes passed, no variables passed. Here we have one integer. Here we have two integers. Here again we have two integers, but the type is different. So this is what is explaining. See, once the parameter length differs, that instead of 1 you are having two parameters, instead of 0 you are having one parameter, that is a sort of method overloading. But instead of passing two integers, you pass two doubles. That is the type of, that is the second type which we discussed, the parameter type. So the parameter type changes. So if it changes, then it's also called as overloaded method, which is the fourth version which is defined out here. And then creating a class and calling the different overloaded methods, you can actually go ahead and see the output. Okay, so this is what I had for overloading. Now let's read about it and see whether it makes sense or not. So method overloading results when two or more methods in the same class have the same name but different parameters. As I said, methods with the same name must differ in their types or number of parameters. This is what I discussed. This allows the compiler to match parameters and choose the correct method when number of choices exist. Changing just a return type, okay, is not enough to overload a method and will be a compile time error. So what that essentially means is that if I go here and say instead of long, in one case I'll return double. Is this overloaded method? It should work fine, right? That is not the case. So if you just change the return type, I mean that's not accounting for method overloading. So Java supports method overloading, but this is not method overloading, so it will get confused that there are two methods with the same name but different return types. Okay. Now it will result in compile time error if you do that. They must have different signatures. When no method matching the input parameter is found, the compiler attempts to convert the input parameters to types of greater precision. Now what that means is that say instead of here you're passing say integer length and integer breadth. Now instead of integer length I have long. Okay, and when trying to call the method area, you're passing it values such as area 1 comma 1. So if you do that, I mean 1 is actually an integer value, it's not a long. But since compiler is not able to find any method which matches this particular signature where the method name is area and the two attributes which are inside it is of type integer, it calculates the nearest possible match and thinks that long is able to match up to it and uses this particular method. And that is what is being referred here, that when no method matching the input parameter is found, the compiler attempts to convert the input parameters to types of greater precision. Okay, and then after that you might find a match, and at compile time right implementation is chosen depending on like the method which you call. So if you have called sum of params, I mean that will be called. If you pass one parameter, 5 integers, this will be called. So that is what is meant by the last statement. So this is all about method overloading. Okay, so the things which we discussed today was about classes and objects and method overloading. Now there are a number of questions which I have come up with. Okay, and these questions are nothing but I want you to write programs. So you have enough knowledge to start writing basic programs. unless you start writing them, it will become difficult for you to understand such things. So that's why I have come with such questions. Some of the people have responded back to the assignments, and it's great that you are working on it. I'll request others to take up the lead and start going through the assignments for session 1, session 2, and session 3, because unless you start doing that, it's going to be difficult for you to understand the complete scenarios end to end. And since I've received some of the inputs for Java session 1, let's discuss about the questions which was out there in the training session 1. So the first question which was out there was, what about what is the first object oriented language? So the first object oriented language is Simula. So what happened is that there is one, just hold on. Just a second, I'm just trying to retrieve uh, one of the assignment answers which was sent by one of the students. We'll just discuss on it so that we all are clear about it. Just a second, let me open it. So the document which I've opened right now, let me share my screen back. So document which I've opened right now is from Reena. Reena has sent the assignment. So thanks Reena for that. I hope you guys are able to see my screen. Okay. So the first question was about the language, which was the first object oriented language. Okay. And the first object oriented language is actually, I mean, you can say it's Smalltalk, but I mean it was actually Simula. Okay. And Simula is actually a simulation language which was developed to work on the say VLSI, etc. And there they had many complex representations, and that's why they started coming up with such concepts as objects and classes, etc. And that simplified their work a lot. So Simula, as you can see, is the first object oriented language, but from there onwards, using Simula and the concepts which were introduced, Smalltalk came into picture. So Smalltalk is you can say it's the first full-fledged object-oriented language which is having all the features of it, but that is not the exact first language. I mean, Simula is the one which actually started it, and then Smalltalk like recently followed it. Now, what is multiple inheritance? So multiple inheritance, as we first of all, Java supports only single inheritance. So what that means is that everything works only in one hierarchy. So employee can have only one parent class, okay, and its parent class will only have one parent class. So there is only one level of hierarchy. But in C++ and maybe some other object-oriented programming languages as well, you can have inheritance for the two levels. So what that basically means is that the employee, say the CO class, it can extend one class which is employee, and say there's one class as board, you can extend the board class as well. That's correct, Nirali, it's a diamond problem. So it extends employee, it extends board. So what happens is that employee class can have some of the methods which is not in sync with board. So it can have, like, say calculate salary, okay, and it might not be adding the bonus here, okay, employees are not getting bonus. Now here in board they are calculating the bonus as well while disbursing whatever they give to the board members on daily basis. Okay, not on daily basis, I mean on monthly basis. So there's a difference. Now when you extend it, you do not know which particular salary has to be called. Or even if, like say, here also you have a INT bonus, here you have INT, like say, number of years in the company. Okay. Now in this case, you do not know whether when I run the program and the CO class extends employee class, whether the calculate salary which you have written for employee, that should be called, or what you have written for board, that should be called. So this can be, obviously there are ways to reduce it or to avoid it, but this creates a diamond problem. Basically the problem comes from two ways, and there could have been solutions for it. Java people could have suggested it, but the very basic idea of why they wanted to start with it, and you can guess that from the some of the things on which the very core Java depends, like one we discussed in the first class, compile once, run everywhere. They are going for the simplicity of the language. The language has to be as simple as possible to be used, and they do not want any additional complexity. Now there are ways in which you can have the features of multiple inheritance in your program. Okay, like say if you want to have additional features, you can have additional methods, you can implement an interface instead of extending two classes. So they have given you ways in which you can have the same functionality implemented, but only one level of inheritance, because they did not want to create confusion. They believed in simplicity. So this is a very basic idea behind this particular question. Now let's come here. Now third is about solid. This one is the one which I want to discuss in detail about with you guys, in the sense that you have to go and read about it. This is one of the basic principles of object-oriented world, and there are some of the things which we discussed in the first class as well. So in abstraction, polymorphism, encapsulation, all these things in one way or the other leads to these things as well. So S stands for single responsibility, which means that a class is supposed to do only one thing. O is open, close. So which basically means that a class should not be open for modification. So in the sense that tomorrow, if you have written some project and you have written 100 classes as part of it, and you deployed that in production environment, so now it's working fine. In second release, you have some additional requirements. You should try to avoid changing the class and see, because if you change the class, the behavior is also changing. You should see if you can extend that particular class. So in the sense that you can inherit it and add some additional attributes if that can help. So O stands for open for extension but closed for modification. Okay. Then L stands for Liskov substitution. I stands for again interface segregation. This again interface segregation is about the interfaces which I was talking about. Okay. And D stands for dependency inversion. So it means that dependency inversion means that, say, so dependency inversion basically means that your Java code should not be creating new objects, and maybe you can delegate that creation of objects to some other place. Maybe you can have an XML to create that. Okay, so that can be done. In that way, you can invert the